Immediately after this talk, if you're interested in the lockpicking village, there is Intro to Lockpicking. There's also, of course, a talk after this. It is Postmortem Forensics. At 5 p.m., the demo party is happening in the chill-out room. That's the room with all the games and the CTF stuff. At 5, the security obstacle course also ends, so if you're interested in doing that, do it before 5. Other than that, dinner at 8, games at 9, formal wear encouraged, right? We're going to play Monopoly in suits.
I didn't plan on formal wear this
year. Well, then I'm definitely going to win the game. Other than that...
Last year I wore a tux.
Other than that, Todd, are you all good to go? Okay, cool. Up next, we have Jason Ritzke. I actually don't know how to say your last name, but I've known you for a while.
It's Ritzke.
Ritzke. Jason Ritzke with I Am Unhinged. Give him a big round of applause. Thank you.
Shut up, HB. I just left this up here. I'm not going to read that because that would be atrocious. I'm pretty sure that there was a warning on the page for this talk that made it very clear that I am going to just ruthlessly abuse the fact that IAM is pun friendly. So is everyone enjoying LayerOne? I am. Because I am. I'm Jason Ritzke. Places you can find me on the internet. I'm RTZQ0. Pretty much anywhere I'm anywhere that you want, that I want to be identified as me. If I'm not this, I don't want you to know that I exist. So if you find me here, this is me. Qualifications is a big empty white square. I actually kind of want to go into this talk in kind of an interesting way. I'm not an information security professional. I'm an operations professional. I'm a DevOps professional. And I have a really great time learning with the DC 562 community and just the local Los Angeles community. A lot of very important security skills, and I think it's a very important thing for my community as it grows and absorbs things from this community to kind of come back and tell you the story from the other half of the trenches, which is essentially what this talk is. This is a blue team DevOps talk coming back to the security community and letting you know kind of how things sit on the other side. Like I said, I hang out with DC 562. We're over there in the CTF room and over there, and there's some of us over here. Kind of a South Bay, Los Angeles area DEF CON group. I work for these people. They do consulting work mostly up in the Bay Area. We do some stuff down here. This is my obligatory shill slide. We're going to be talking about IAM just a little bit in brief. Just quick from people, who here uses AWS like on the regular? Like a few people, like 25%. Who's used anything that's not EC2 and S3? A few people, okay. So we'll be going over IAM just in kind of a basic level. This is not going to be an IAM deep dive. There's way too much because every single API call in AWS is drilled down into minute detail, down to a specific file or specific endpoint or specific resource level. So this is a gloss, and if it bores you, I will not be angry if you get up and leave. I'm going to be talking about kind of the overall current landscape and how things are going in terms of what we call cloud native deployments and how that's influencing how we're starting to look at security on that side. Basic overview of how you actually interact with IAM, construct IAM policies, and then a little bit around automation and security auditing tools for IAM, and what you can do to get a little bit more visibility into what's currently deployed. I'm not going to talk about most of the tools in AWS except to very briefly talk about, this does this, this does this. That's why you should care in an architectural sense. I'm not going to talk about EC2 security because that's primarily Linux security with a dash of network firewall from the Xen hypervisor layer. and anything OS or app specific. And this talk will be barely useful to anyone who's already got pre-existing AWS knowledge. And it's not a fun talk. This is very serious. I'm not kidding. What is IAM? This is a sweet potato. This is a yam. That's a distraction. This is IAM is AWS authorization. Authentication can be done through IAM, but realistically it can be done through a lot of other places too, and it federates with IAM through something called the Secure Token Service, which I'll go into in just a minute. Really, IAM is basically a holding tank for a bunch of users, a bunch of groups, a bunch of roles, which are essentially just user-like anchor points they don't actually provide sign-in, but allow you to attach access policies to. And there's an API, of course, to put things into IAM. Plus the other things that aren't IAM but are closely related, and the Secure Token Service is really the big one. So the Secure Token Service is a mechanism by which you can request temporary authorization credentials from IAM, well, from AWS for use with IAM to get to give federated services and applications provisioned access for a finite length of time. There's a few different mechanisms for doing this. For those of you who love SAML, this is their generalized recommended layout for doing SAML roles, where you have your little, come on, not bright enough. Okay, you have a client application there on the bottom, reaches up to an identity provider, gets an identity, flings it off to Secure Token Service. Secure Token Service flings you back a temporary credential, and you use that to access a bucket that would normally be private. You can do SAML. You can do OpenID validation with all those fancy OpenID providers. That's great. They have this cool service called Cognito. I say it's a cool service. You don't have to use it, but they recommend using it for any of your mobile stuff because it can automatically do access synchronization between multiple devices, which can be very convenient. And then we have their Active Directory connector, which is something that you actually put inside of an AWS VPC typically and have it dial back into your network to talk to your Active Directory system, so that when you log in, it does a STS call and gets you temporary credentials. But that's kind of we call it a virtual AWS appliance, similar to how you might deploy an appliance on internal VMware infrastructure. All three of these things could easily be their own talk, so we're just at a very high level kind of understanding how STS fits into the picture. There's also some libraries for talking to STS to get authentication in your app. From a high-level perspective, IAM and STS work very closely together to kind of compose the topology of how do I get authorization credentials to perform actions somewhere within the AWS infrastructure, as has been the case since about 2011. We'll get into that a little bit. So AWS has an authentication and authorization system. It's not really interesting. Why do we care? One of the things that's easy to forget about AWS is just how mind-bogglingly big it's getting. I know for a lot of my career I was focused very much on-prem deployments and maybe some occasional VPS deployments, and I didn't realize the mind-blowing size of AWS. There was a time when we actually knew all of their IPs, and so if you had like large enough systems, you could actually see the number of things flowing through your switches that were going to AWS IPs, and you could guesstimate the percentage of internet traffic they were. We can't do that anymore because they've gotten better at shell companies, and we don't know which IPs they own. But they've gotten big, very large. Let's see. And then this came out. earlier this year. ThreatStack is a cloud security awareness company, and they did an audit of their own customers because they have a cloud security awareness platform, and you install it and you give it credentials to your account, and it just tears through your entire account and looks for everything that's insecure. And they found that 73% of the people who cared enough about security to buy their very expensive product were totally hosed, just wrecked. Basic stuff, security groups open to the entire world for an AWS instance, EC2 roles that had full access to the entirety of their AWS accounts, insane levels of control. I'm sure we're all familiar at this point with this is fine, dog. So when I started working with AWS, the biggest thing that when IAM came out in 2011, right, this was back before AWS was really, they were very excited about it, but they weren't pushing it very hard. They have, in the past couple of years, started doing this thing where when you create a new account, they actually give you these big red angry boxes that yell at you until you turn on IAM and multi-factor authentication and stop using your root account to do everything, which is a good step because from like 2011 to 2014, every time I worked with a client, I was having to make them do that because people aren't taking that step. And still, I will walk into places and find that people have left the root account accessible and are sharing root account passwords because we still aren't beyond post-it notes on screens, and that doesn't. People are still having that problem even when they're administering public cloud infrastructure. The other thing, and this is to touch on something that Dan Tentler was talking about earlier, is the the connection from the VPCs, from the virtual private clouds into your network to do identity federation. When you're doing the Active Directory connector, right? Dialing back, putting it on a local network segment through virtual private, through a VPC VPN connector. Before that, we actually had people who were just whitelisting the external IP of their network and using that to authorize connections. So assuming that you could send traffic outbound, there was no way to actually secure and fence that off. So in some ways, things have gotten a lot better than they used to be. Like 4 years ago, doing AWS stuff, the authorization landscape was awful, and no one had any idea how it worked. Now some people are getting an idea how it works. It's getting much better. Also, if you've ever had to deal with security audits, you know that benchmarks are not often like really fresh. I did a Unix security audit last year, and people were shocked to find out that I didn't have any FTP users, and I was severely curious. That's not a thing that I typically have running on a box. So we still have people that are being trained on old benchmarks, and so as we move, every 2 years or 3 years, the speed at which AWS is moving is pretty fast. We tend to leave these security benchmarks behind. This isn't unique to InfoSec in the sense, and this is something that Sam Bones has talked about before when he talks about why SQLi is still such a big problem. We teach people how to do things with one set of rules, and then they go into production and they're expected to magically know how to do something with another set of rules. They were taught with the non-prod rule set, and then they're supposed to deploy with a different rule set. Every time I watch a video on how to do AWS and it teaches me how to do IAM, it teaches me how to do it wrong. And there's not a video out there that teaches you how to do it right. So how do we expect these people to know how to do this well? So bottom line, AWS is huge. And a lot of it's configured poorly. Not AWS the platform, but AWS the platform as it's used by people. And that provides both a bit of a scare and an opportunity for us to, come in and help clean, help tidy up, because when we're rushing to market with minimum viable products, when we're rushing to market to get their app out the door, at some point, someone has to come in and go, we need to clean up this MVP. Your MVP is showing you've left some database credentials lying around on the floor. So let's think about what we know about applications on the internet, right? This is a nice, delightful flow chart, right? You've got your sensor on your IoT device. It goes into your IoT firmware code, which is well written. It goes into your infrastructure as a service configurable network, which you've configured well. That pushes into your API, which you've written well, which goes into your server, which goes onto your platform APIs, and then goes into your database, which is all hosted on your platform. And all of this is clean, and you've written it well. We know that the flowchart is actually much more like this, right? Your IoT sensors are supplied by a company who didn't care about their firmware. Your IoT firmware is not well written. Your API is a cluster with no authentication and no endpoint authorization. Your server is well configured. No, it's not. Your network has ACLs that are insufficiently granular. And your database is, I can insert rows here, I can insert rows here, I can delete things. Because we had to get the IoT thing out the door. If we're under the illusion that the embedded software is somehow magically worse than the back-end software, I think that's silly. It's just as bad. Oh, I'm getting there. Add to that the fact that there's a lot of stuff in AWS. I mean, we talk about EC2 and S3, and there's some people in the room who've dabbled a little further. This is, as of like 2 days ago, this is the list of services that you get when you pop into the console. There's a lot of stuff here, and a lot of it's the platform as a service stuff, right? The other stuff's pretty well defined, but when you get into stuff like data pipeline, or Elastic Container Service, or Elastic File System, or simple queue service, or simple notification service. You've got entire queue and database platforms that are managed for you. And so the security questions of how is this configured, unless you're actually auditing AWS, kind of drop by the wayside. And so what you're concerned about is how is the user configured their segment of it. And the answer is typically pretty not well. But there's a lot of services here. And they kind of are going into the cloud native model, right? How things are starting to be built. We're starting to see a whole, if you look at the Google, I should have gotten the Google Trends for cloud native because over the last year. Cloud native, hot new buzzword for building stuff using all of those platform as a service tools that aren't EC2, because that way scalability is delivered to you for free and you don't have to worry about the configuration. We kind of need to talk about all the platform as a service stuff real quick. So this is the typical curve that we're used to dealing with on-prem security worries, right? The API is, what? I can't make this any bigger, actually, because if I do, it will do terrible things. I'm sorry. This one is, at the top we have the API we wrote, and things get kind of more bad as we go down because the infrastructure doesn't get the prioritization or the attention that it needs. Once we've got the app up, we're good. So once the app has all of its feature set, we're happy. So we have the API we wrote, the network we maintain, the OS we maintain, the hardware we maintain. Things just kind of get shittier as we go down. The cloud model is kind of flipped, right? The hardware is handled by Amazon, and generally speaking, they have a really big logistics infrastructure. They hire really smart people. They spend a lot of money making sure that if something falls over, you can click a button twice and you get stood up on a new instance. There's always compute for you somewhere unless US East 2 falls over again and we lose Netflix and Twitter. They maintain their own OSs, so your RDS databases are always up and clean. They maintain their own network, but on top of that is a section of network that you maintain, right? The section of virtual private cloud. That's the stuff that you set up. And then the OS and the code and the application that you maintain, and that's where we're concerned about the problems, right? Maybe someone wants to pen test Amazon, and if you do, good luck to you. There's probably interesting stuff there. I suggest you lawyer up. But I'm interested in the top two boxes. I'm interested in the things that people do as they're rushing to use the platform, because as I'm going to show you, the platform is actually pretty deep. Is this? Oh, this is Delaware North. So the other nice thing about Amazon is that occasionally we get case studies. This is too small even for me to read on my screen. But this is the Delaware North case study for where they were describing their architecture for moving files around in their system. All of these little segments are some internal internal AWS service. None of them, sorry, there's a MongoDB cluster up there. That's the only thing that's EC2. Everything else is platform as a service at this point. So your access controls for your API are going to get really important because your OS level security at this point has basically become irrelevant. The only thing you care about is your access control at the platform network layer and your access control at the platform authentication and authorization layer. Turner also kindly supplied us with their little layout. Again, there's no EC2 here. Well, there's some EC2 in the bottom right corner, but we've got simple notification service. We've got Lambda functions. We've got AWS managed Elasticsearch and their API gateway, right? All of this stuff is all managed platform services. So our security model has to entirely start to focus on how we set the knobs. Certs. AWS likes them. There was a time period where they didn't have a lot of them, and they had a problem getting customers from a lot of controlled industries because they needed HIPAA compliance and they couldn't run their stuff on the public cloud. There's a lot of cloud fear. And so AWS's response to this was, we'll get our system to have enough knobs that we can claim delegated responsibility, get all the certs, and fight this complaint. And you can actually see this. The cloud security confidence has gone up something like 20% in the last year. They have a lot of certs. God, that's tiny. Sorry, this was set up for, I think, 1920, and I think this is 720, but anyway. FedRAMP, HIPAA, ISO 9001, ISO 27001, just all the frickin' certs. They have a whole page. It changes probably once a year when they add something new on it. They have a lot of certs that they maintain. And they operate on this delegated responsibility model, right? Everything that you can't touch is certified, and everything that you can touch is not certified. So any mistakes that you make there can blow your certification out of the water. So they just say, okay, well, we're good on all of these, and now it's your problem. So let's talk about the R problem. We've got some AWS people. I assume most people here can look at JSON. This is a JSON document. A JSON document is made out of some bits. It's got strings, numbers, objects, arrays, booleans, nulls. This is my brief JSON refresher before we go into. So this is a JSON document. It's got strings. It's got numbers. It's got arrays. Arrays are ordered. That'll be important in a second. Let me get closer to this microphone. And you can put objects inside them, which they do. So let's talk about how IAM uses them specifically. We have a version field. It's always set to the second value, but the first value is the default because AWS hates your fingers and wants you to type that every single time. They have a GUID that you sometimes need, but not all the time. So have fun finding that in the documentation because it's not all in one place to tell you where you need to have a unique identifier for your policies. Principles is fun. Principles is the thing that we typically care about. This is the who gets to do the thing. Also, just to go over this really briefly, this is using something called an ARN, which I don't think I have a slide for, which is awful of me. An ARN is an Amazon resource name, and that basically spells out the subsegment of the AWS API, what it is that we're using, basically what section. In this case, we're talking about IAM, and we'll have an AWS account ID here, which will be whatever our specific account is, and then user and username. You'll get the same thing with SAML or with Cognito roles too. And then we have our actual policy statements. Policy statements look like this. We have the version, which is always set to the second field up top. We have a statement identifier, which, again, sometimes has to be unique and sometimes doesn't. An effect, which is typically allow, but can be denied in some cases. and then an action, which is a series of API actions that are allowed to be taken. So that's the what you can do. So we did the who, that's the principal. Action is the what, and the resource is the resource is the to what it can be done, right? And that's another ARN. And in this case, you can see that these can get pretty darn granular, right? This is a specific file in a specific S3 bucket, which is good. I mean, it's nice to be able to whitelist and blacklist individual files in a specific S3 bucket for individual users. That's the kind of fine-tunability we want to see on these knobs. The problem with fine-tunable knobs, if anyone's ever had to administer a network firewall before, is that if you go about whitelisting individual ports on individual boxes, you'll be there all day, and rapidly you find that the work scales as the amount of granularity you want to add scales. I actually kind of already ran through this, so I'm just going to skip ahead a minute. Writing all those things by hand would be awful for the reasons I just described. You can sit there and you can write, S3 policy documents, and you can use the AWS CLI to fax those policy documents up to AWS, or you can go into the console and you can click a button and you can paste the policy documents in, and it'll be like, okay, that's a good policy document. I will enforce these rules. And that's great, and it's going to take you forever, and you're going to be sad because you have a manual process to instantiate those rules into your cloud service. And your developers will be sad because typically they have to have an interaction with this because, we're kind of helping them to understand how to do the security and helping them to do the enforcement, but there's some kind of an interaction here where we have to understand what it is that they need access to. So it's going to make everyone's lives miserable. AWS has a lot of these canned AWS managed policies, and they're fantastic. And they have role policies by business role, right? They have administrators, they have power users, they have all this stuff. They have individual API canned roles, so read only, write only, access per API segment. So if you want access to S3, that's great. If you want access to simple notification service, that's great. There are these canned policies. Of course, it's the nature of the fact that if they're managing a policy, it can't apply to anything unique to your infrastructure. So every canned policy ends in an asterisk at the top level of an API, right? It kind of has to, by definition. So if you want to get granular, you have to start deviating from those canned policies and making them specific, and then you have to maintain them. And the more granular you want to get, the more you have to maintain. And then you have to not only maintain it, but make sure that the version that you wrote and maintained is actually pushed up to IAM and is the enforcing version that is actually what is acting on all of those systems. Because it's great for you to write an IAM policy and have it on disk on your laptop. But it doesn't matter what's on disk on your laptop or in the Git repo if that's not what is in the platform right now. I'm a DevOps person. I instantly reach for automation, including when I'm doing security stuff. AWS has this tool called CloudFormation. You throw out JSON manifests, and it automates your system and builds stuff and tears it down when you want it to. And you can do things like you can define users, right? You build a JSON manifest, you put in groups, you put in profiles, and then you put in you define the user, you define a role here, and then you see here there's a little JSON section. You put in your JSON policy document right there, and you want to actually write the policy. You go in here and put the policy document in here. You actually write a JSON blob and stick it in your JSON blob. It goes in there, and and then you've got your JSON blobs together, and it's fantastic. If you don't like JSON, you can use YAML, which is even better. So YAML CloudFormation documents, I don't like YAML. And here's why. I find this impossible to read because, let's see. I removed that slide. There are 63 different ways to have a multi-line string in YAML, which I find to be a little challenging to read. But YAML basically delineates the same thing as JSON. It tells you there's a role, and it has some properties, and it's got a policy statement in here, and that's what's important, that allows you access to a service. In this case, this is a full root access policy. So this is a root role that gives access to everything. Don't use this one. Write a better one. But you throw that up into CloudFormation, it will instantiate that as part of a stack for you. Let's see. Okay. The problem is that this is vendor-specific platform code. I hate vendor-specific platform code. I hate spending all the time writing all this automation stuff and then be stuck on AWS. I have AWS certifications. It doesn't mean that I like them. So I would rather do something else. If you're using config management systems to automate and harden your infrastructure, you can use your configuration management system. Most of them have plugins for most major cloud providers. So if you're using Ansible, you're using Chef, you're using Puppet, whatever, go ahead and roll that out. You can roll your own. There are automation systems. You can just interface directly with Bodo if you're a Python person and enforce your own API stacks. And that's kind of how some other people have written the tools that we'll get you in the security auditing tools section. Or you can use Terraform. Terraform's great. Everyone's using it. Super cool. Multi-cloud platform automation. And you write manifests like this. And it's its own domain-specific language, which is great. I have to learn an entire new programming language just to do the new hotness. It actually also accepts JSON. This is why everyone should just know JSON, because everything can ingest it at this point. And like OSSec and OSQuery both spit out JSON manifests if you want to look at the output of your system. So if you can just look at the JSON output and read it, it's kind of nice. But anyway, you can write your policy statement, and you'll notice here there are some variables. You can actually do programmatic insertion inside Terraform. The best part is, if you learn Terraform, you can take those lessons that you've learned and move them over to Google Cloud, or move them over to Azure, or move them to OpenStack. It doesn't care. So you're using the same knowledge you have about hardening cloud platforms and applying it in multiple locations. Now here's the security person part. I can write Terraform stuff and automate my platform and push out my roles and tell all of my people that I know exactly what's out there. But I don't actually know exactly what's out there. I know what I put out there. I know what I myself ran, but if someone else has access or someone did something and didn't tear it down and left the company, I don't actually know what's active on my stack. This is a state creation tool and state enforcement tool of a set of state that I want to be present, but it doesn't remove things that I don't want to be present. And that's when we get into auditing tools. Auditing tools, every security person's favorite tools. Scout 2, who knows NCC Group? They're good people. They're good people. I like them. I like Scout 2. I think it's way better than the other alternative that I'm going to show you. The only unfortunate part is that it's AWS only. It's great. It can give you these nice big breakdowns of like all the ports that are accessible within your system and which ones are way too large and where your security groups are too big. And it can show you all of your access keys here. It'll tell you, oh, you have a user with 2 AWS access keys available. Why does he have 2 active access keys? That makes no sense. And he doesn't have multi-factor turned on. What's up with this dude? We need to fix this. And then there's Security Monkey. Security Monkey is a Netflix tool, and it's written by, it runs on both AWS and Google Cloud. It's a little glossier, and it does most of the same things, but personally I find it to be, I think the NCC group has a little more experience in this area, and they've written a tool that better fits the needs of someone who's actually trying to find things rapidly that are wrong within their infrastructure. But Security Monkey's all right. It does most of the same stuff. It's a little complicated to use, and it's clearly coming from a Netflix kind of we know best kind of mindset, which they often do, but it's still irritating. So you should look at both of those. I realize this is a very high-level gloss, and I wanted to give there plenty of time for questions at the end, because I think there are going to be a lot, because I tried to cover a lot of area at a high level. So, yeah, question time. Okay, I'm going to start from front to back, so I'll get you in a minute.
Okay, I apologize for getting here just a little bit late, but it looked like you were going over a lot of the standard identity provider, service provider kind of web SSO stuff. And if I could be excused getting on a soapbox, anybody who uses that as a basis for their security has decided that it's more important to be web-based than to be secure.
If you're on AWS, you've already decided that. Like that's pretty much, you don't have any other options on AWS.
And then you can Kerberize it, for instance, which was the next thing I was going to say, was that you're denying yourself the opportunity to solve a problem to solve the needs.
I don't disagree with you that that is a much more secure approach to the problem. The reality that I am faced with is that I can walk into a company and tell them, you can use Kerberos on all your private instances, or you can use a fantastic magic box that auto-scales your database for pennies on the dollar. They don't care. I don't disagree with what you're saying.
Call people's attention to is that there's been some really good work done in the IETF the last couple of years in the token binding working group, where they have been trying to come up with solutions to that problem, where tokens, your web tokens, are actually bound to something meaningful instead of a local TLS tunnel that has nothing to do with the TLS tunnel going to your actual service.
And so I want to draw a distinction here. Like, there are lots of really good talks at this conference and other conferences that address what is best. You know, as Conan would say, what is good in life. I understand that there is what is good in life. There is also
I'm being kind of cute.
well, and it's needed, right? It's very much needed, because if there's no balancing act, Edgar Jix, I can't pronounce his name ever. Edgar Dijkstra, sorry. Complained a lot about the conservativeness of business when it comes to building computer systems, and how they will always recoil from what looks a little dicey on the monetary proposition in order to, and this leaves us with uninteresting and unidealistic computer systems. And I agree. I don't particularly, like I said, I have AWS certifications. I use them heavily in my work. That doesn't mean I like the way the platform has gone. On the other hand, it's massive and it's growing and there are things on it, and if all that we do is say that's no good, in the meantime we have shitty light bulbs talking to shitty APIs hosted on shitty instances, configured with shitty network ACLs talking to poorly configured databases. Like, it's just this compounding pile of I agree that we need to focus in on making things better, but at the same time we also need to make sure that the house is not actively on fire. We need to do both at once. I don't want to discount your point at all.
Yeah, so do you know if Amazon actually dog foods their own machine learning APIs? Because I read something recently, and if you tell us when they're fake, it's fine, I'll accept that too, but I read something recently like the Alexa AI actually isn't. It's a whole bunch of Mechanical Turk people programming in the stuff, to support the Alexa services and whatnot. And supposedly like the Alexa engine is supposedly the test bed for the ML stuff, but not really. So I was just wondering if you.
I know Amazon has leveraged Mechanical Turk to stand up data sets in the past. And I know a lot of people have used Mechanical Turk to just bootstrap data sets in general. It's actually, I've talked to a number of startup people who have done that because it's a cheap way to get people to do data analysis and get a whole bunch of constructive base data into your algorithm. Yeah.
What I'm asking is, like, do we actually have any confidence that the ML APIs that Amazon's selling is actually good? Because their own dog food says mechanical Turk, which is not ML.
Well, okay, so I'm going to respond. I do see where you're going. I'm going to respond with a somewhat philosophical question, which somewhat philosophical response, which is, well, yeah, this is the if you are unable to tell the difference between whether it's mechanical Turk or it's not, and you're comfortable with the price point, does it matter? There's your Blade Runner answer. That's well, I don't know. Humans are remarkably fast at babies, but no, it's a terrifying thought, isn't it? Right? No, it doesn't scale the same way. But then again, as far as figuring that out, I don't know. It's really hard to get data out of Amazon. They're really tight-lipped about any of that stuff, and they shut down leaks pretty quick. So.
Yeah, it just seems like the ML APIs that they're selling at best are actually not dog fooded internally, and they're using anybody who's using the ML APIs as the guinea pigs to
Why would you dog food an algorithm internally when you can get people to pay you for the privilege of dog fooding an algorithm?
I mean, I'm not saying it's ineffective. I just don't.
I wouldn't be surprised. Yeah. I mean, I wouldn't be shocked. I don't think that's a.
Right. It's just that I lived through a version of that with some Apple APIs in the past, and those APIs didn't live very long. So that's all.
Yeah.
It's all good.
Anybody else? I'm up here for a little bit longer. Okay. I can get off this stage? Okay. Great. Fantastic.